Hello dear viewers, I'm back from work and we are back for part 3 of episode 14, I think it's 14, yeah, where we have spectacularly failed to put a man in a suborbital trajectory around Kerbin, but we are on the verge of succeeding of putting this beautiful probe around Val, or at least on a flyby past Val, don't know how to pronounce that. We're currently on a flyby past Val, where we will attempt to slow down and do a propulsive capture. We had the heat shield, but we jettisoned that to save delta V. There it goes, to save weight and increase our delta V. This has ruled out a aero capture at Joule, so it is going to be a propulsive capture or nothing. We're going to try and do some seismic data, which we can't in space. Maybe some temperature data. We can't do that. Sometimes you can do this temperature scan in space, but not always. I don't know what that's about. And the gravity data is bringing us back a lot of science points. This is our show pony for this mission. You might be wondering why I didn't bring the mystery goo or the materials science bay. The answer to that question is wait. This space probe is about as light as it gets. We get the two deployable solar panels, which really are a must if you see how far away the sun is, and also a little bit as insurance. These two could get rotated in such a way that they don't catch any sunlight, and that would lose the probe. Then we have some fuel. This is basically all the fuel that there is for the probe, and 2 batteries. This makes it lightweight and allowed for a rather small rocket to carry it all the way out here to Val. So with that out of the way, it is time to time warp some. We're at 300 days into the mission, 299 to be exact, and it's 12 more days until we end up at Val. Now at 100,000 times time acceleration, it works out to about a second a day. So here we go, at 100,000 times is 1, 2, 3, 4, 5, 6, 7, that's a week, 8, 9, 10. There we are, quickly coming up on Joule, slowing it down to 10,000 times time acceleration and reducing that to 1,000 now. Here we are entering the system. It is quite a picture. I'm going to take a screenshot of that for the thumbnail. Here we go, a screenshot of that. And here we are at a somewhat lower altitude, and let's try a science experiment with the gravioli detector there. Now I could twist the camera and fumble around for that detector in the dark. Instead I'm going to twist the spacecraft around and get that gravioli detector here. Log the gravity data. It's still high over Joule. It's a million times closer than it was, but still obviously pretty high. Looking at the map view, we are quite a bit closer to our Joule encounter. This will now happen in 10 hours. So I'm going to put the time warp on that. Get 17 science points back home. So at 100 times time warp, that would be about 6 minutes. Still too long for our liking. So we're going at 1,000 times time warp, approaching Joule. We are approaching Joule, but we are most importantly approaching Val. We are currently set for a periapsis of 435 kilometers. I don't know if it has an atmosphere or not. This is part of the reason to, part of the goal of this mission is to figure out all these things. But we wouldn't encounter any difficulties at 430 kilometers. What we need to do there is brake at the periapsis and try our darndest to get a orbit going. So I'm going to slow down the time warp so we cross into the sphere of influence relatively slowly to minimize any errors we might incur there. And look at that, we are entering it almost directly beneath it, which if we do get an orbit will means we get a polar orbit, which actually is pretty great because then we get to map the whole of the planet. Now we are coming in pretty fast, so we are going to have to apply a lot of delta V in order to get a circular orbit around Val going. Here we go, this is an orbit, and the scary number is 6,000 meters per second of delta V. Are you kidding me? We can't expend that much delta V. Preliminary estimates put it at about 1,000. This is crazy. So we are going to try it. We're going to input as much delta V as we can. We might as well start now. I can assure you we don't have 6 kilometers per second of delta V in this rocket. So probably our flyby, maybe we can do something else. Maybe we can change our trajectory such that our periapsis becomes very low, so that we get a closer flyby and then escape off into interplanetary space. We can do that. We lose all hope of staying in the Joule system, but this looks like something that the rocket might be able to do now. We're going to slow down all we can, hope to get into a Joule orbit at least, and possibly then we will be able to... Ooh, look at that! If we do this, we get a Tylo flyby as well. Maybe if we continue like this, we can use some gravity assist or something and see a lot of moons. We're going to try that. We're going to go for a Vol flyby, and then we are going to go on to a Tylo flyby, because apparently an orbit is out of the question. Going to tweak this so we get the lowest possible Tylo periapsis. Let's have a look. This is not happening. This is not happening. This direction, and yes, this is what we need. So here we're going 150 kilometers, 70 kilometers over Tylo. That looks like it could be exciting. We have to do this burn in 2 minutes, and before it's that time, we are going to do a gravity reading. And scanning from orbit provides a clearer picture of the internal makeup of Vol. This is of course what happens in real life as well, when we scan space in order to find out what's happening. This burn is rated at... Oh, there we have Vol. I was looking at Joule, but there we have it. Our interesting research target for this mission is quite small actually. And we are going to get closer to it. Our orbital speed is 6 kilometers per second. Wait a second. How can a capture move be... Oh yeah, we're going to accelerate some because we're falling into it. I was wondering how a orbital insertion burn could be more than the velocity that we have, because that would actually that would turn us around. But we are going to pick up some speed before getting here, and evidently Vol is quite small, and that rhymes. Vol is quite small, so it has a very low orbital velocity. As of now, we are at 0.25 meter per second squared. Gravity acceleration due to Vol, so that's not too much. It's not too much at all. Compare that to 9.8 meters per second squared on Earth or Kerbal, and that's quite a lot more. So an orbit around Vol is probably out of the question. That is going to happen in a second mission, hopefully, if we can do an aero brake at Joule, which we cannot do anymore because we ditched our heat shield, geniuses that we are. So I'm going to fire up the rocket, perform this burn. Now I'm going to wait a little bit. This rocket puts out delta V quite rapidly, so I'm going to wait until the node happens in about 15 seconds, and then I'm going to burn for it. It's a pity, because I was hoping to establish quite a low orbit around Vol and see what it is made of, or does it have an atmosphere, or how much the gravity is, or those things. But we're going to have to settle for some pictures from orbit, and of course the gravity data that we are getting right now and giving us in-game science points as well. 435 kilometers. And we are almost at our periapsis, passing by at 6 kilometers per second. And these are the closest up pictures that Kerbal kind has ever gotten from Vol. We are spotting some nice craters. Oh, we've missed the burn node while marveling at the planet. It looks like there are plenty spaces to land, so we could attempt that in a future mission, but not now, obviously, as this thing has nothing even resembling landing legs. So here we are, probably set up for our encounter at Tylo. a 24-kilometer encounter setup with Tylo, this outer moon, and that might give us another chance to circularize or to get in orbit, because we are, I think, getting a reverse gravity assist from Tylo. I'm not sure if I worked that out correctly. At any rate, we will get more science done, because we are also visiting Tylo, obviously, and then we can do our no holds barred deadpan braking maneuver. First, let's have another gravity data in space over Vol, transmit that home. And remember, we don't have any cache left in the mission controller. This mission is it cache-wise, and this is not going to give us any cache either, because our man did not get in a suborbital trajectory. So hopefully we can convince the boffins at home that we are actually capable of some interesting space flight. We are leaving Val behind now and heading on to Tylo, scouting this Julian system. And while our scientists had put their hopes on Val, if Tylo looks better or different or nicer to be, our research goals might shift to that moon. Here we go. 1,000 times time acceleration will get us there in no time. Do it a blip at 10,000 and back to 1,000 quickly. We don't want to overshoot as what happened to Jeb. Reducing that, and no, as the way I see it, Tylo is only going to accelerate us out of the system. We're getting a periapsis of 30 kilometers, and that is where we will try to slow down into this system. Let's have a look at that. Well, it's a lot less than it was around Vol. It's only 2.5 kilometers per second. I don't think the rocket has it in it, but we shall see. We shall see. First things first, and a grav max. We are too far from the object. Right, so there's no measurable gravity from Tylo according to the sensor. I wonder if it's broken. If we log the gravity data, this planet has lower gravity than anticipated. We shall have a look. I hope it doesn't have an atmosphere, because we don't have a heat shield, and encountering an atmosphere would be quite simply disastrous. Transmitting home some science. We are still carrying the solar panels, and we are still capable of doing that at least. Here we are, 120 science points from that gravity scan over Tylo, and let me tell you, we will be able to get a scan close by it. We will be able to get a scan from the space close to Tylo, because we are coming in low. Oh yes, don't you believe it? And hopefully we'll have sun exposure at that altitude, so that we can do a few transmissions. We will be braking constantly while passing Tylo. Let's have a look at it. There it is. It's now obscured by the sun. We are in eclipse. We are eclipsed by Tylo. So no solar power for us at this moment, but fortunately we will pass out of that shade momentarily. The Julian system is quite pretty. There's Jewel, there is another moon, I think that's Lathe, and I'm not spotting Val anywhere. Quite pleased that we did manage to get a probe out here at least, even though it doesn't quite have the delta V to stay here. For that we really should have aerobraked at Jewel, but seeing how that went quite spectacularly wrong last time we attempted it, it is probably safer to go this route and get some guaranteed science in. Let's see if I can find the gravity sensor here, because that's really difficult in the dark. Communitron. I really should have put some lights on the spacecraft only for this purpose, so that I could click the sensors when I'm not in the sun. Too much to ask, the spacecraft designers didn't think that to be necessary. We're still dropping quite spectacularly fast. We're at 500 kilometers of altitude now. Here we go, the gravioli detector. Great. Let's have a look at that gravity data. It's 2.5 meters per second squared now at 400 kilometers. This thing has some gravity, man. 200 science points, transmitting that home. And it's always scary, well, not scary, but you have to keep in mind when transmitting in the dark, if you run out of power, you lose control of the probe. So only transmit if you have enough power. And these datas, they take a lot of power. This one costs over 300 powers to transmit, which leaves us with only about 94. This is enough to control the probe for a few hours or minutes at least, but it's not enough to transmit any more data, so we're not going to even attempt that. Instead, we are going to hit up that time acceleration just a little bit to... Oh, another thing I'm hoping is that Tylo doesn't have any tall mountains, because we are coming in 30 kilometers, and Mars, for instance, definitely has mountains that reach that altitude. So let's hope that Tylo does not have those. It's time to light up the engine to attempt to stay here. And we are breaking into a beautiful sunrise over an alien moon of Joule. Can we see it in the sky? There it is. It's other moon, and the rocket is exhausted. We're going to leave that behind, I think, and move on with just the space probe. We are again rising in altitude quickly. This node passed very soon, very rapidly, but we are still braking, and we have about 50 more seconds to burn before we slow down enough to have established an orbit, and we just might make it. The fuel is running out. No, we're not going to make it. Who am I kidding? We are leaving this planet behind while in space near Tylo. That's great. We are going to transmit the data. This will deplete our battery, but we are in the sun, and I hope that the engine will keep firing, that it's just new control input that doesn't work. So yeah, we can't control the probe anymore. Oh, it recharges enough so that we can keep control, it's just not transmitting all the data. Let's see what our trajectory is doing. Oh, stop! We made it! We are, in fact, in orbit around Tylo. We have a periapsis of 30 kilometers and an apoapsis of 5.8 million kilometers. 5.8 million meters, 5.8 thousand kilometers. We did make it. Great. We have a tiny amount of fuel left, not a lot at all. Less than one of these toroidal tanks. But oh my god, we made it to Julian stable orbit of one of the moons. Wasn't the one we were aiming for, it is not Vol, but it is Tylo. So we can't do any seismic scans, and I think it's fair to say that Tylo doesn't have an atmosphere. We came in pretty low, we came down to 30-40 kilometers and didn't encounter any air. And we did see that the gravity is fairly strong, comparable to Kerbal actually. The size looks about the same as well. Looks to be slightly smaller. This is my own ocular judgment. Looks to be slightly smaller than Kerbal, and judging by this orbital speed, it has slightly higher, but definitely comparable gravity. Speaking of that gravity, let's log it again and transmit that again. We are in the sun. Nothing is going to stop us from transmitting. So we are going to leave this probe here after it finishes transmitting. It does have a little bit of fuel. It might be useful at some point to do something. There is a weird crack on Tylo there. I'm not sure what that's about. Perhaps it's evidence that this planet has been constructed rather than formed naturally. And say hello to our first Julian stable probe. This is not going to leave the Joule system, and it will stay here indefinitely. Pretty good, if I do say so myself. It might even get a sneak peek at Vol, and from this trajectory it is fairly equatorial. Perhaps we will be able to set up a very cheap transfer to Vol. I'm not so sure about how to go. I'm not sure how to go about that, but we might be able to do it. Anyway, I'm going to head back. Oh no, I still have to wait until this data gets uploaded. There, the data is uploaded. The batteries are as good as recharged. Here they go, completely charged. And I'm going to leave this probe here like this and going to the space center, because we sure got a lot of science. If we look here at the R&D station, we have 922 science points. The first thing I'm going to unlock with this is, wait for it, nuclear engines. Nuclear engines, not for burning fuel but for annihilating the fuel. They are what we will definitely need if we are to put boots on Vol or even Tylo. Vol will still be our target. The DICE decided that a few missions ago, and we had got our first look at it. Doesn't look terribly large, doesn't look like it's got an atmosphere, even though we didn't get that close to it. But to get a large manned space station or even lander there, we are going to need the atomic rocket motors. Fortunately, it says that radioactive exhaust is harmless, mostly, so it's good. Research that for 300 points, and it's the first endpoint we reached in the tree. This doesn't go anywhere else. So we have 600 points remaining. We can get here some aerodynamic parts that we don't like. We can get some lander gear that we don't really need. Rovers. I think we should get some rover parts. That looks great, because exploring planets or moons definitely needs some rovers. Going to keep that in mind. Large electronics, large electrics, bigger batteries, bigger solar panels. Great, but so far we're managing just fine. Ion thrusters, great for superb efficiency. Seeing how we don't have that much cash in here, we might need to go cheap, although these definitely are not cheap. They will enable a very light satellite with tons of delta V, so we're going to go for this, the ion part. So our next budget on the mission on the shoestring to Joule might very well sport an ion engine. This is so that we don't need a very heavy launch vehicle. Here we get unmanned tech with traces of sentience, a flatter version, and even lighter probe core. That is quite welcome, actually, so we might get that. What do we have here? Advanced metalworks, heat shields, large the docking ports. The docking ports is something else that we will really need to make a large mission to Joule to Vol possible, so we can dock multiple parts together in space. We're going to wait for this, not quite get it immediately. And here we get large control. We don't need this quite yet. Now we're going to go for the unmanned tech increases, the advances in that direction. Yeah. And our next mission on the shoestring will have an ion thruster. We'll have all the science experiments and we'll go back to Vol. So here we go, research that for 300 points. Behind this we get advanced unmanned tech. What's this? Another probe core. A remote guidance unit. I have no idea what that is because we're already remote guiding everything. Large probes. A large probe? Great, this all looks a little bit superfluous to me. We have a lot of interesting new technology and no money to use any of it. If we look at our missions that we can choose for tomorrow, we can go for Vostok 1, the suborbital trajectory of a spaceman, which will give us a lot of money actually. We might have to do it. And we can do Kerbal 2, we did this, Vostok 2, Vostok 3, go places. So these are things that we might have to end up doing. We can send a probe to Juna. This is boring. We are going to Vol already. But then again, a Juna probe could be done cheaply and we could get some good money out of that. So I might do this actually. Comsat contracts here. We might. Wow, so we should be able. Yeah, I'm going to build a rocket that does a lot of these missions to get a good amount of money for our next Joule mission when that launch window comes back around. It will be a bit. That concludes today's mission. 3 parts because I had to go away from the computer a few times. horror of horrors. Thanks for watching. I hope you liked the exploration of the Joule system. Tomorrow, something commerce oriented, and the day after, hopefully, a mission back to Joule. That is if all goes well. Recent days have shown that not everything always goes that well. Anyway, thanks again for watching. Hope to see you back tomorrow. Share this with your friends if you liked it. Subscribe and like it, of course. Those are the primary ways you can help me and show that you like watching these videos. I always like to see those like counters and subscribers tick up, obviously. So thanks to all of you that do that. And well, I'm not sure what else I have for you today. Space is awesome. See you tomorrow. Goodbye.